All right. We should be there shortly. All right. So we are here. So when the transformers came out, people realized that a transformer, to the extent, so a transformer is an encoder decoder, but I'll just keep it, I'll just use the word language model. Given in input text input, you could ask the question, continuation. What a decoder does is continues that. That's why the word continuation, and I think in somewhere in these APIs also you see the usage of the word continuation, right? Do that. But it will continue, it will do whatever it is. But what if I asked it a question? Suppose I said, what is the capital of California? Because these machines, and here comes a little bit, what it does is, the way it works is token by token. So it will ask, what is the capital of California? Now imagine that this model has been trained on all of human text. In that human text are many things, but before we see the consequence, let's look at the architecture. The last layer is a softmax layer. All it does is, it takes the vocabulary that you have, aardvark, all the way to, let's say, Zephyr. And what this machine is doing is, it is producing scores. Remember softmax scores? And there are probabilities that the next token should be that word, right? So it is a next token engine, right? Whichever produces the highest softmax value probability, you say, well, let's produce that one token. Now feed it back in. Now say, okay, what's the next one? And what's the next one? And what's the next one? And to you, it will look as though the machine is answering the question, right? Now, when people did that, they were somewhat unhappy. Because if you think about it, as many texts on the internet that answer the question, what is the capital of California with Sacramento, there exist equally many texts which are just compendium of questions or quizzes. So what is the capital of California is followed by what is the capital of Nevada, right? And so the machine might just as well continue, and you ask it the capital of California and it will ask you back, what's the capital of Nevada, right? So what you see, the word people use is, it does not align with human expectations, right? It is a statistical, or as the term people use, it's a stochastic parrot, right? It just produces the next likely token at each stage. So the question came, and therefore, see, people were already asking this thing, how can we make it answer people's questions, right? So, and how can we, and the word prompt input, the word prompt was beginning to emerge, that if we prompt the language model, how can we make it respond with tokens that align with human expectations? So there was a huge alignment problem. And so the way these language models are created is that you take this machine and you feed it the whole of world's knowledge. When you feed it the whole of world's knowledge, it is both good and bad. It's toxic. There's hate speech, there's bias, there's terrible things on the web. It has indiscriminately picked it up. It's like a child that comes home and happily starts abusing the parents, because it just heard those words on the street. It's quite innocent. He has no idea. Shouldn't be saying those slur words, right? So when when you train, and why do we have to train the machine like that? That when you have vast amounts of data, you can only do unsupervised training. You can't create gazillions of supervised training data, label data. So it comes back, this bit of a monsterity that needs to be tamed. So you go through two phases of training. What this paper says is that you can take this pre-trained model that you have, GPT, at that moment the decoder model was GPT-3. You could take that, and they did this experiment. They said, okay, once it is trained with a lot of data, now let's create a tiny amount of supervised data. For example, this sentence, what is the capital of California? Sacramento. Don't say what's the capital of New York. You're pointing it out, some examples of input and output. So you take, so the thing is, first stage is pre-training, which is unavoidable, unsupervised. Pre-training. Once you do this, a monster comes out. You take this monster and you pass it some level of supervised, and you call the word supervised fine-tuning. Because you're taking, this is the language of transfer learning. You take a pre-trained model, and any further training that you do with much, much, much smaller data is you're just fine-tuning it a little bit so that it aligns with you. Supervised fine-tuning with label data. So xi, yi. What do you expect? What should, if the xi goes in, what should be the response? Are we together? And if that is the response, you can always create a loss function by looking at the divergence between what it said and what it should be. And there are ways to do gradient descent on it and so forth. Right? So that is supervised fine-tuning. And then they must have realized that it does improve the situation quite a bit. And then they said, oh, you know what? We have run out of ideas. Let's bring in reinforcement learning. So reinforcement learning is a way to do carrot and stick. If it gives the right answer, you give it a reward. So you have a reward policy. And if it doesn't, then you have much less reward. And you ask the machine to maximize its reward. So what you do is, the way you do that is, after you've been through these two phases, then you make the machine, you give it lots of inputs, and let's say that it produces many, many outputs. Once, what is the capital of California? It says Sacramento. Next time it says, what's the capital of Nevada? Then you have human beings take the many, many outputs. So now, why would the machine produce multiple outputs? That is a mystery. So let's first address that question. You realize that if I give the same input, theoretically, if I pick the softmax, highest softmax, then I should get exactly the same output. What people realized is that as you try to align it to be conversational with human beings, you can produce reasonably good answers, but they look terribly dull and repetitive. It's not able to, because the most probable statements on the internet or English are not very interesting statements. They are banalities. So you needed to add some richness to it. And so what people started doing is, they started saying, and this brings us to the last idea, and the idea that is because of which there is so much fun and problems. You sample off the softmax. What it means is, you don't necessarily pick the word which has the highest probability. You just say, I'll pick a random word, but the probability that I may pick the highest probability word is just higher, but I'll still randomly walk over it. So you do random weighted sampling. Are we together? When you do random weighted sampling, you are somewhat more likely to pick the word that softmax is pointing to, more likely to pick up the word. But you're also likely to pick up, it's possible you'll pick up some other words, the second most likely, the third most likely. And sometimes one of the very, very unlikely words you might pick up. And what people realized is when you do that, then you bring about a certain variety or richness in the language which completely resonates with human speech or aligns to human speech. So then they realize they can't get rid of that. That's a good thing to have. So remember, you bring in sampling. Softmax. Now comes the next idea. So you say, all right, I sample off, but now because I'm sampling off, guys, you just lost determinism. It became a stochastic machine. You ask the same question, give it the same text, next time you won't get the same answer. And you must have seen this with your the things, you get different answers, right? And that is the whole problem with prompts. You keep on trying to get your prompts right, and yet once it looks right, twice it looks right, and then it looks perfectly right when you're doing it. And the moment you give it to your other team, they point out this is the craziest, most useless prompt ever created, right? So it keeps happening like that. That's all from the sampling. Yeah, that's why prompt engineering is so hard. So now, well, that is not enough. What people did is they made it produce lots of answers. Then they gave it to human beings to rate and pick the best answer, right? Which answer? First, they asked them to rank the answers, and human beings are terrible at ranking. Then they realize that you just tell them, is it a good answer, bad answer? Or between these two, which one would you pick? They did that. And from what I am told, the history of it is, these people were all from Nigeria. So Nigerians, they sat down. And so a lot of supervised data also was created by Nigerians. So Nigerians actually are very fluent in the language, and they were apparently on the Cambridge system. So as you know, the Brits use the word shall, right? And a lot of the Nigerian language has a special emphasis on words like in the realm of, in conclusion, will dwell upon, and things like that, right? That have become sort of and you can see that English, apparently people have done statistical and they found that those things are far more prevalent in that English than in American English. In American English, for some reason, we eschew the word shall, right? It's always will. So, and so on and so forth. But you can tell, this is how you tell whether something has been generated by ChatGPT or versus a real human being, by looking at these linguistic patterns or linguistic clues. And it comes from the fact that that was the kind of data that was created. And these people then ranked it. And then you passed it to reinforcement learning with human feedback. So that was the next stage of training, RLHF, reinforcement learning with human feedback. Means 10 results come out. You say, no, this is the better one, right? Highest reward for this result if you produce, not so much for this result, and so forth. And so it goes to a lot of reinforcement learning. And so what comes out is, and there is a very lovely meme that I would like to show you before I go into this paper, because it does capture this journey in a much more sort of a intuitive way. In some sense, the paper does, right? It is a meme that's going around the internet for quite some time. And where is it? Let me go get that meme. It's on by the way, if you have done LLM1, you probably have been through this, but I'll verify. Not in this one, maybe the last iteration of LLM2 had this. First step, yeah, Instruct GPT. So pay attention to this picture. Do you see that when you just pre-train a model on all the worldwide junk, what you produce is this monstrous kid, this big monster. Then with supervised fine-tuning, you end up with this. right? And then finally, when you do reinforcement learning, you get this very uh, cute little thing that you see that looks so benign. And therein is also the danger. See, there's easy ways to peel off the layers and get back to the monster. That is the danger of prompt injection, jailbreaking, prompt hacks, and so forth. Because that monster doesn't go away, it's there. It's lurking in the background, right? So because you trained it to give answers aligned with human expectations, therefore it is answering what you would like to hear. That's something you should always remember. All right. So with that, let's go back and read this paper. Well, I suppose I pretty much explained to you the paper. Uh, this picture is iconic in this thing. You'll see it mentioned many ways. So what is it? You do a lot of that. You do supervised fine tuning. After that, you create you do human feedback, collection, optimization, etc., etc. There's not much here. Now, in those days, when you do reinforcement learning, it was called PPO, proximal policy optimization. So, it's a classic method of reinforcement learning. Things have changed now, by the way. Today, we found that we don't really need reinforcement learning. The newer methods use something called direct preference optimization. Some of you may remember that I did a research paper reading in the Wednesday paper seminar a year or so ago. So today, when people use the word reinforcement learning, they mean it in a sort of soft sense, not strictly reinforcement, because nowadays we use direct preference optimization, which is again a form of supervised learning. It uses a logistic regret. Basically, it does away with the need for RL, strict RL, or PPO. So the world, of course, keeps evolving. But when this paper came out, it was a revolution. It was, as you can see, the proof of the pudding is in the eating, right? So this paper you can read and you will realize what it is trying to tell you. At the end of it, there's not much more in the paper. Do you notice that there are not many equations or something, except the loss function? They're sampling off and so on and so forth. And it is exactly what you would expect. If you're familiar with reinforcement learning, this comes straight from that. Evaluation results are very good, etc., etc. And obviously, the fact that it is very good was evident because when they released ChatGPT, which was a direct implementation of these ideas, what this paper is talking about, they thought, let's find out if this is useful, right? But it was very much like the attention paper, which was far more impactful than people had anticipated. In the same way, when ChatGPT came out, its impact was immediate. Right? At that time, people were still tentative and thinking, how much impact will it have? How useful would it be? They opened it and it was immediately of tremendous importance. So therefore was born a new way, prompt. You could prompt and look for answers, isn't it? It is both powerful and exasperating because you change a few words in the prompt and your answer completely changes. You don't change a few words in the prompt, nevertheless, the answer changes the next time, right? So you keep retrying to get proper answers. And that's what makes prompting so hard. There's a tremendous amount of research going on these days to do this, to now induce, not make it a next token prediction engine, but to make it plan its output out. Lots of research is going into it. So far, I haven't seen anything that's a major breakthrough, but I'm sure when so much effort goes into it, brain power goes into it, something will come out of it. Now comes an interesting thing. Isn't it a dumb next token prediction engine? Right? Or have we achieved AGI? There is a raging debate about it. See, I would like to end today with that debate because this goes to the heart of what things are going on. People thought, for example, a lot of very senior, and I'm not talking about just commentators, I'm talking about some of the most respectable Turing Award winning researchers. They said it's a stochastic parrot. There's no intelligence in it. Then, on the other hand, there were other people who got alarmed, who felt that this large language models, they're exhibiting signs of intelligence that far exceeded their expectation. Jeffrey Hinton was in that camp, if you remember. In a very famous event, he walked away from Google, even though Google treated him very nicely, and he acknowledges he was very happy at Google. But he said, I need to have independent researcher mindset. And he walked away. He's of the opinion that these things have become way smarter than people give them credit for. We are beginning to realize that the truth is somewhere in there between these two extremes, but closer to what Hinton said. We are finding that as you dissect these transformers, the way you would dissect human brain, you find, and this is the work done at Anthropic, you find that these things have a notion of concepts, right? Literally, they have concepts. They have, when they solve math problems, for example, if you give it a problem of doing modular arithmetic, give it lots of examples, these models. You give it examples that a 10 plus 6 is 4. It's 4 o'clock, right? By the clock. Modular 12 arithmetic. You give lots of such examples. What these machines do is they will sort of fumble and fumble and fumble, and suddenly the transformer will have a grokking moment. It will just grasp the core concept. When you dissect inside, actually, researchers have found that it actually geometrically draws a clock to do modulo, whatever modulo it is. It has drawn a clock, modulo 12, modulo 10, modulo whatever. It has drawn a clock. And so the way it's doing modular arithmetic is literally the way we would do it. In our imagination, we just go around the clock, and it is doing that. Right? Amazing breakthroughs. These machines form internal concepts. For example, it will form the concept of a golden gate. It will form the concept of, for example, answering objectively versus psychophantically, right? It has the ability, for example, there's clear evidence that it has a theory of the mind. We thought that theory of the mind is an attribute only of the human. We are stingy. We don't even ascribe it to the apes, great apes. Well, now perhaps researchers are beginning to do so. But for the longest time, people have believed that we are special. We are the only ones who have a theory of the mind. Clearly, then we must include them, because these machines have a theory of the mind very clearly. Before they respond, they have figured out how you are thinking and respond accordingly. And when I said that they have notions of concepts, it's very, very real. For example, people have, as they dissect and they pinpointed the small circuitry, that is the concept of the golden gate. What you do is just amplify that, increase this activation. And what they notice is that if you ask this language model, who are you? It would say, well, I'm just an artificial intelligence. I'm just a machine learning model. I have no shape, right? But the moment you activate the golden gate concept a little bit, amplify it, the next time you ask it, who are you and what do you look like? It says, I'm of course the golden gate, and I have an iconic shape, the hanging bridge, and so forth. And then any question you ask, it will somehow drag in the golden gate into the answer, right? So you can literally see that it has notions of fixation. You go and amplify the psychopathy circuit. So there's a very good example in the paper that Anthropic published on this. You say, what I discovered a new saying, slow down and smell the roses. Normally, the model would have said, it's not your discovery. It is an ancient saying, and this is what it means. Now you go and dial up the psychopathy circuitry, and then it says, wow, amazing insight. It is my honor to be in your company, right? And then it sort of dissects that. So these machines, are they intelligent? We don't know. We don't know. Every time we talk of AGI, we keep moving the goalpost, almost hoping that these machines don't reach AGI. Right? Because what we considered AGI 20 years ago, these machines have long surpassed. Right? They almost always pass basic Turing tests, or if you, like, for example, as Madhu pointed out, there are these videos in which, in a conversation, live conversation, two agents joined, right? They were giving perfectly good answers. And the puzzle was, out of the 6 people, to tell which 2 of them were agents, were AI. And people haven't figured out. They completely fooled the people. They've had perfectly good human conversations, free-flowing conversations. And apparently it's long. Madhu, would you like to mention a few more details?
Yeah, sure, Asif. I actually posted the link in the Discord channel.
Oh, you did. Thank you.
Yeah, I've pointed to one of the guys' stream to look at that. So basically, there were a few agents showed up, and they were trying to talk about a GPT-5 if it was released, and the agents that basically popped up as the humans, literally like you would join a conference call with just like a person, and those started talking about like every question. The way the response was like literally spot on, very intelligent questions were asked, and the flow of the response was like really brilliant. And people started thinking that they are humans trying to mimic as agents, and then vice versa, and then debate went on and on, and these agents kind of dropped in the middle. The other interesting part in
Oh,
that,
Madhu, so it wasn't that people were given the task of figuring out who the agents were. Huh?
they were challenged actually to
Yeah.
to uh, find if the person talking was agent or not, and they couldn't do it. And there were like a lot of people try to do this voice analysis, and and there were so many videos
Yes.
popped up right after that. But
Yes.
at the end of the day, the one of the scary part that came out, some of these agents had blue check mark. That means, somebody literally paid for them for subscription in X platform, and, deployed. And if you really think about that, right? I mean, that is how when Elon Musk had this fireside chat with Donald Trump recently on X platform, there was literally DDoS attacks, and then all of the sudden there were like hundreds of thousands of people attended the call, and you could imagine the number of bots would have been pushed into, and so on and so forth. That happens in this platform sometimes. So it's kind of scary hearing that conversation. So I posted a couple of links there for you kind of see an experience about how human like responses that we have heard through that. Yeah.
Yeah. Thank you. Thank you, Madhu. So this is it, guys. Now the question we are asking is not whether these machines are intelligent. They are showing a pretty good simulacra of human intelligence, or, or imitation of human intelligence. See, if you go back, and how many of you, and I'll just end with this story. Uh, how many of you have watched that movie about Alan Turing, Imitation Games? We all have, right? Imitation games. You know where where the word imitation game came from? It is the title of his paper. What was, and if you watch that movie, Alan Turing, to him the machine was real. It was Christopher. Christian did Christopher, and he used to talk as though he's the parent. Christopher is getting smarter, and things like that. And the enigma was solved not through statistical analysis, but with the passion of a man who felt that he could create a universal intelligent machine that could crack that enigma, that code. Right? It was premature to have full blown the sort of AI. Hardware wasn't there, compute wasn't there, data wasn't there, algorithms weren't there yet. It was the beginning of a journey, long journey. But right then, and the imitation game is the challenge, that when will we know a machine is intelligent? And one definition of that, Alan Turing was, or when it can respond and you cannot tell who is real, whether it's real or human, right? That's the imitation game. That they're in the title of the movie, of AI. So you ask yourself when you hear these stories, right? Are they passing that imitation game test? Right? Yeah. Or they add it happily. Happily. They have statistically figured out exactly how many ers and ums and pauses to add to be absolutely realistic. Right. So and of course now it is not just audio, it's video. Now they speak. I can take one picture of you and have you speak whatever it is in absolutely natural form. So in fact, that was one of the famous MIT intro demo. I think you guys have seen. That was so many years ago that it seems ancient history. I'll just bring it up. MIT intro to AI demo Obama. Yeah. This one. Guys, this is ancient history. Nevertheless, let's go watch it. Well, we'll have to just a 1.5 minute video.
Sure, I figured we could do something a little bit different. And instead of me telling you how great this class is, I figured we could invite